Hi, dudes. This is probably best aimed at folks that haven't seen circuitry type of stuff before. So if you've seen it before, it can't hurt to check this out. It won't be too long. But if the idea of a circuit and specifically some quantities that are associated with typical circuitry types of situations, simple circuits, if that's totally foreign to you, definitely worth a watch. All right, so circuitry basics. First of all, I mean, we can start over here with what's the purpose of a circuit. Well, people say things like, "Well, it's to move charge." I mean, I guess that is what circuits do, but it's not really their purpose. I mean, just moving charge is all well and good, but who cares really? The purpose of a circuit is to make those charges do something, and really what it is to turn the energy that those charges have into a different kind of energy that, that provides something that we need. So what I'll say is in general, the purpose of any circuit is to convert electrical energy into some kind of other energy, right? And that really, this blank here and this blank here kind of go hand in hand, right? A simple circuit has a battery or really some sort of what we call power supply, and a something, and the switch isn't the important part really, but the something, you know, really links right to, well, what kind of energy are we going to turn the electrical energy into? Are we going to turn the electrical energy into light? Well, then this says a light. Are we going to turn the electrical energy into, mechanical energy? Well, maybe this says like a motor. Or are we going to turn electrical energy into sound? Well, maybe we say like a speaker or something like that. Yeah, sure. All right, so, what goes in that blank depends on what kind of energy you want to turn electrical energy into. But let's just say, why don't we say, for this case, why don't we say a light, and into light. All right, well, we can, let's draw here. Let's see, battery. All right, battery looks like this, right? It's one of those like D batteries. And what do we got here? We got like the switch part. Okay, so that's like, all right, imagine one of those like Frankenstein switches, right? Where you got like these things here and like a hinge, and this thing has like a knob on it, and then you can swing that down and it makes contact with this thing here and this wire. All right, this wire comes out, and then we got, let's see, one of these like holders with some screws on it, and there's a light bulb in there, and the light bulb's got a filament and stuff, right? And then that, all right, so there's my simple circuit. All right, well, that's all well and good, except if we're, what's the word? Depending on people's artistic ability, that can get us into trouble. All right, so here's the deal. Let's agree on some what we call schematic representations of typical circuit elements. Like, well, the one that's kind of duh is a wire. Well, we use a line to mean a wire, right? So here's a wire. Sure, no problem. Now, well, how about this? A battery, we use, now I'm going to draw, no I won't. A battery, we do this. Some parallel lines that are, you might want to do another set. Some parallel lines that are centered on each other, but some are shorter than the other. All right, this would be the wire leading into a battery, the wire going out of a battery. All right, a light. There's a few ways to do this, but I usually just do it like this. So there's the wire coming in, the wire going out. There's a circle with a little loop in it. The reference table and one of them does something like that. So it looks actually kind of like a filament in a light bulb. All right. A switch just shows wire coming in, sort of open door, and then the other wire coming out. Shows you that you could close that switch and complete a circuit. Very standard is something that we call a resistor. Oops, resistor. And that looks like that, zigzag. All right, and what's a resistor? Well, we spend a lot of time talking about that. But basically, anything that goes in here is a resistor. They're just what we call specialized resistors. All right? But in a lot of cases, we'll talk about really pretty pointless circuits that just have resistors in them for no real reason. So it's kind of odd, but whenever we can, we'll talk about some good applications of using specialized resistors, like a buzzer. How useful is that? I don't know. A light bulb, that's more useful. But resistor is the most common thing to see in a circuit for us, from a problem-solving standpoint. All right, so this circuit, while sure that's a pretty good artistic representation of what's happening, our typical schematic representation of this would look something like this. Battery, switch, bulb, back to battery. Even if it's not in a square, why not make it as a nice, neat-looking sort of square? Okay? What else? Well, that's kind of it. All right? Now, quantities and variables and stuff, things that will measure quantities we need to be familiar with. There are a few. One of them is called voltage. Variable V. Units, volts. Which we also use capital V. Variable V, unit V. The definition of voltage is what's called potential difference between 2 points in a circuit. Doesn't have to be in a circuit, but we're talking about circuitry. Now, potential difference. Potential, by definition, means energy per charge. So when we say voltage, we're talking about difference in energy per charge. We're talking about how much electrical energy charges have lost, or the amount of electrical energy lost per coulomb of charge, per unit of charge. All right, so voltage isn't really energy, but it sure can be thought of in a similar way to energy. Okay? Okay. The next, let me shrink. The next quantity that we'll concern ourselves with is current. Variable, of course, capital I. Units, amperes, or amps. We just use capital A. Definition of current is the rate at which charge passes a point in a circuit. I equals Q per T, charge per unit time. Okay, fair enough. definitional stuff. And another big one is resistance. Resistance. R, measured in ohms. That's a Greek capital Omega. And definition of resistance, well, resistance is resistance. Yeah, resistance is resistance to, that's as circular a definition as you can have, but it's the, geez, how else do you say resistance? Not saying resistance, the resistance to flow of current. Please think of a better word to use than resistance. But what else can I say? Everything resists the flow of current. Things that do a good job of not resisting the flow of current, well, we use those to conduct current. So metals are good conductors and typically have lower resistances than things that don't conduct very well. All right? That's a good enough start for now. And notice that I've left this depends on, controlled by stuff for later. All right? That's going to be a lot of your job, is to figure that out. So voltage, current, resistance, the three big parts of a common relationship that we'll come up with ourselves, ideally. Now, next, I got to talk about. I need yeah, need that. All right. I need to talk about ways of connecting circuit elements. There are two primary ways. One is we say in series. To connect things, to connect circuit elements in series means to connect them one after the other, sequentially. Like, well, here's a resistor, and then there's another resistor after that, and another resistor after that. Those are resistors connected in series. Here's a circuit with a battery and a light bulb and a resistor and a switch all connected in series, one after the other. Okay? The other big way to connect circuit elements is what's called in parallel. And there's a few, I don't know, you could say sort of say like separately. Separate, what's that? Separately? I don't like separately, because usually I say like simultaneously. Yeah, sure. I'll do both of those. Separately / simultaneously. And what that means is, well, notice, in a series connection, we have one path, right? If an electron's going to go from here to here, it's got to go through every one of those resistors in a sequence. If we connect resistors in parallel, what we get is a situation, or what we could have is a situation like this, where if an electron's going to go from here to here, it's going to go, or electrons, well, that electron would go, you know, into one of, or through one of those resistors separately. Or we could say electrons could simultaneously be going through all three of these things at the same instant. That's not a great way to say it. But anyway. All right, so here is a circuit with, here's a circuit with well, a resistor and a light bulb connected in parallel. Here's another circuit with a resistor and a light bulb connected in parallel. All right, big deal here. One path. Big deal here is multiple paths. Okay, so this is very likely review for lots of you, all right, but necessary for all of you. If you haven't seen it before, then hopefully, that doesn't even say multiple, does it? Yeah, that's it out. Multiple, good. Hopefully, if you haven't seen this before, this gets you. It'll help when you get to that next video, which is about connecting multimeters. Okay. Okay. Bye bye.